All right.
I'm going to take your mask off. I can't see it.
I'm going to take it off. Don't you worry. How are you? I'm calling you from the bowels of the lab here.
The human brain is the most complex structure in the known universe, and we are in the middle of a scientific revolution to understand its inner workings. Join us for a conversation with world-renowned neuroscientists as they visit Rochester. I am Dr. John Foxe, Director of the Monte Institute for Neuroscience at the University of Rochester, and you are listening to NeURoscience Perspectives. Tanya, thanks so much for joining us today in these strange times where we can't be together. And I've wanted to interview you for so long. Obviously, you and I know each other for many, many years now. In some ways, you're an amazing American story. You started out your life in Riga, in Latvia, and with stops in Poland and Denmark before your career in the US. Would you tell us a little bit about that? Like, how did you end up in America? What drove you to these various places to get your training?
I came to the States on a NATO fellowship from Denmark for a year to the University of Maryland. And it was also an accident. You know, in the old days, we used to request reprints. So I requested a reprint from Bill Hodders, who was a professor at the University of Maryland, who worked on pigeons. And this is at the time I was studying memory and a little bit of vision, but mostly memory in the pigeon as a model system. And I wrote to him just asking for reprints, and he saw my name, and then he looked at Denmark, because he's been to Copenhagen apparently some years before, and then he said, "What are you doing there? Why don't you come and work with me?" So I said, "Oh, that sounds good." So I applied for a fellowship, NATO fellowship, because that was one thing I could do. I was I was kind of a graduate, postgraduate student in Copenhagen at the time. It was at the Copenhagen University. And I got it, and I went.
And Tanya, can we turn the clock even further back to your childhood in Latvia, and what took you from Latvia to Poland? And
I was born in Latvia. I grew up it was the Soviet Union at the time, so I was Russian speaking. They were both Latvian and Russian speakers. Of course, Latvia was dominated by the Russians and the Soviet Union at the time. In the Soviet Union, during Stalin times, people who actually wanted to leave couldn't leave. Almost like now, we can't go anywhere, right? We
right.
can't go anywhere. Well, it's kind of the same. Anyway, and my parents really wanted to leave the country. And when Khrushchev came to power, he allowed a lot of people who were stuck in the Soviet Union, and my mother was from Poland, she could prove it. They let us, it's called repatriation. They let us go to Poland. It was on the way to Israel. That was the plan, because Poland was a lot freer than the Soviet Union. So we came to Poland. You really want the details?
Yeah, of course. I mean, it's an amazing story. And I mean, so the plan was to keep going to Israel, but you stopped in Poland and stayed then.
Well, we were there waiting for my brother, who didn't live with us. And then he was a lot older than me. He just got married. He didn't want to leave. Another long story. He married a Russian girl whose father was a real Soviet patriot, who did not let her leave.
Right.
And you have to have a permission, even as an adult, of your parents' permission to go anywhere. So they stayed behind, and it took 10 years. And eventually my brother joined us, but it took 10 years of my mother crying her eyes out and trying to get a visa for him. Eventually he made it, but only after they told him that he has to get a divorce.
These stories are of high interest because at this time in history too, and maybe we won't get too deep into politics, with the sort of rise of autocracy again, people have forgotten what it was like.
That's right. In fact, the way people were able to live in this country for so many years, they've completely divorced from politics. Well, my life was never divorced from politics. It was always completely part of it. My parents could not talk to me about anything political, because I would go to school and I would tell people, and then I would get arrested. Right. So I never knew anything what was going on. And then eventually we did come to Poland, and it was communist, of course, but it was freer.
Yeah.
And I finished high school in Poland, and then I went to the university, Warsaw University, to study psychology. And it was my country. I had no interest in going anywhere.
How did Copenhagen come about?
Again, politics, right? So the Jews in Poland, who were completely assimilated, including me, suddenly became the fifth column. There was open anti-Semitic campaign everywhere because there was a lot of unrest and demonstrations because of what happened in Czechoslovakia. There was Prague Spring, and Dubček came to power, and the Poles, well, we at the time wanted to have democracy too, just like in Czechoslovakia. It wasn't called Czech Republic at the time.
Yeah.
So there were demonstrations, and everything was blamed on the Jews, just typical. There was an announcement, a short announcement in the paper on the front page of the Życie Warszawa, which is the main Polish newspaper, that said all the Poles of Jewish origin who plan to leave the country should apply before September 1st. After that, the procedure will change. That's it. So what do you think happened to the 15,000? Whatever remaining Jews there were, and we were all quite assimilated, and wasn't really, even though it was written down in your passport, it said whether you're Jewish or whatever. We didn't want to go to Israel. We knew we needed to leave. And there were 2 countries in Europe that were accepting Jewish refugees. It was Denmark and Sweden.
Amazing, yeah.
My parents went to Sweden and I went to Denmark. And the reason for Sweden is because my brother was with them already by that time. He just came. And he didn't want to go to talking about politics and how it controlled him, he didn't want to go to a NATO country. And Denmark was in NATO, Sweden was not.
Right.
So that's why they went to Sweden. And I didn't want to go to Sweden. I wanted to be in Copenhagen because I already had a colleague who I knew from Warsaw, from the same institute, who was already there. His name was Ivan Divac. He's a well-known basal ganglia researcher who's gone now, but he was there. So I said, okay, well, I know one person there, so I went there.
Fantastic. I mean, really an amazing story of
and at the time, I was at this Institute of Experimental Biology. I was getting a clinical psychology degree, actually, which I got, master's in clinical. And I also started doing research on the brain and on memory, actually. So I was working in Konorsky's lab, and Konorsky this was my claim to fame, Konorsky was a student of Pavlov, so that's pretty good.
Yes, very much so. Good lineage.
I was doing a thesis at the time using a dog as an animal model, just studying short-term memory. Believe it was auditory short-term memory. So this is what my thesis was, but I wasn't planning to go anywhere. And had to finish my thesis before September, right? Otherwise, they would throw me out of the university. I had to apply before September. So I did. Got a letter from Konorsky, which I still have, which is cool, right? And applied to go to Denmark.
I
got a visa, and I couldn't take my thesis with me or any document. It had to go through the Dutch embassy. It was weird, complicated. You couldn't just take things with you. Yeah. And you had to get permission from all of the various government institutions to actually leave. So everything, I have all of the documents just signed by the bureaucracies, and I got on a train.
I think it's instructive to youngsters today what people had to do to be successful in that time, and somehow you, by hook or by crook, you ended up in Western New York at the University of Rochester, which is where you spent the bulk of your career. And I'm sitting right now in the University of Rochester, where my own lab is. And one comment I had was that clinical psychology degree, I can attest to the fact that it served you well over the intervening years, because what people who won't know necessarily, but except those of us who've been here at Rochester with you, is that you're somebody everybody went to with problems when they needed them solved over the years, and that you always were a really deeply compassionate person. Which brings us to my next question, because I'm going to come back to your science, but I'm very interested in the fact that you have spent a long, illustrious and very successful career as a basic researcher, but now you're down at the National Institute of Health taken the call to public service. Here's a question. Is there something that you've learned since you went down to NIH that surprised you?
I'm learning a tremendous amount about the review process that we fight so much for, right? What it actually takes to give us money. We're very often upset and unhappy and right about, oh, it's unfair. It's extremely difficult to get right.
So many exceptional people competing for so few dollars. It's bound to be difficult.
People, and also the review process itself. It's quite interesting because people who run those SROs like me right now, the scientific review officers, it's not their field most of the time. They don't know the field. So there's a lot of information online. I can go and look you up. And yes. I can find out what your expertise is, who is like you. So you could actually say, somebody like John Foxe, you literally click, and there's some keywords that go with you. The expertise, research interest, blah, 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 all of that, right? Yeah. And then if I cannot get you, even though you would be the perfect reviewer for me, I can go through and find somebody who has similar expertise. Very but good. This is how a lot of SROs work. At the moment, I'm very new, I'm really lucky because I can pull names out of my head, which I do. Because I know the community. It just happens that I was very lucky that they really want me to work on Brain Initiative.
Can you tell our audience a little bit, just quick background about the Brain Initiative? They'll have certainly heard of it in the news, but just quickly what it means.
Well, it's really started in 2014, I think, and the funding came in, and it's really quite good. And it's BRAIN, BRAIN, stands for Brain Research Advances in Neurotechnology, something like that. That's what makes it. So it's all about developing the most advanced approaches to the global study of the brain at different levels. So there's a lot of push of developing new technology, but that means recording rather than from one neuron at a time, recording from thousands of neurons at a time, data analysis, all of that. So there is a really good amount of money now to try to change the way we approach systems neuroscience, of course, right? But at the same time, there is a big push on the networks, of course. We're studying, it's all networks, right?
Right, yeah. And so you have your own efforts have a concentration on invasive brain mapping in humans, right? It
happens that some proposals came in, and this is something I could do. I mean, I don't know, I haven't done any invasive brain work, right? Of course, in humans, but I've done it in monkeys forever, right?
Yes, yeah.
Right, so it was kind of natural for them, and I know the field so I got out, I ended up with 8 proposals to do. They're big, but they're just 8, right? And so the focus of this particular program, which is this invasive program, is, even though it says clinical trial, I don't know, have you seen the RFA on this? It says clinical trial, but anytime you have humans, it's called clinical trial.
Yes, yeah.
The focus is really not on clinical trial, trying to come up with some ways of improving human condition yet. Is trying to understand the mechanisms. It's very much close to what you are really interested in.
You know, one of the things that can be difficult to explain to folks is why it's so important to do basic science. I mean, your career was defined by doing fundamental basic science, agnostic as to, for example, a disease model or something, something that you were trying to cure. And people might say, well, why are we spending money to do this when we should really be spending the money to do disease?
We are spending money to deal with disease. There's no way you could understand the disease if you don't understand the organization of the brain. We know that let's say Parkinson's has major problems with frontal lobe, among other things, right? And major problems with the basal ganglia, right? So we are not going to understand and figure out what to do with that particular disease if you don't understand the connectivity and interactions between those regions. So having an opportunity to do it in humans is tricky, right?
Yeah, absolutely.
At the same time, it's very unique. So there's some things you cannot really do in animals very easily. Well, you can't do it at all if you study language just like you do, right? Among other things, you can't do this. But you look at mechanisms of language processing in humans. Now, how do you do that? You can't make holes in humans' heads, just right. But this is opportunistic. So you have patients with epilepsy mostly, who are going to have surgery. They are already instrumented, so there are already electrodes in their brain. So the idea in this program is not to add more electrodes, because you really can't do this, right?
Yeah.
To use what you have and try to come up with clever behavioral tasks, right? Where you could actually record already where you are, in the locations where these electrodes exist, right?
Yeah.
But then you have to come up with really clever behavioral tasks, right, to whatever question you're going to be addressing. And of course, appropriate recording techniques and data analysis, which is the key. So the experimental design is as important in these experiments, if not more, as it would be working with non-human primates or mice.
You're making two really, really crucial points. I love the opportunistic nature of it, right? We don't do surgeries in humans so we can record their brains. It's because they've already had the surgeries. And the other part is that you can't fix something that's broken if you don't understand how it works in the first place. And that's the key to this. I wanted to get back to your own science. I want to ask you a really straightforward question. You spent a career studying the nature by which the brain represents information over time, this so-called working memory. Could you give us a couple of big insights there, things that you really...
I have to move you back in my career, because it is
Fair enough.
I mean, my main focus has always been, ever since Poland, was really relating brain and behavior. It's really, whether it happens to be working memory tasks, which are much more recent in my life, except for the early stuff in pigeons, but generally, right? I'm really a vision scientist who has always been trying to understand how sensory information or visual information is processed in the brain, in cortex in particular. There is not a single task that you ever perform, or your subject or yourself or anybody else, that doesn't include, if you do have any kind of sensory signal, you will always have a mechanism. You will need a mechanism to retain it, even very briefly, particularly in working memory, because there's no behavioral task that doesn't involve working memory.
Right.
So this focus on, it sounds cooler, working memory at school, right? Motion perception, yeah, it's good, but it's basically inseparable, I believe. So you just asked me about the working memory, right? It has a cool factor that people like to pay attention to, but I think it's separable from the rest of the work that I've done actually in a cat for many, many years, really relating what specific regions in cat cortex, what is its role in being able to make a decision about visual stimuli. It's a decision making as well.
What a profound privilege it has been to work with you. You and I only overlapped here for about 5 years. You're so well known in our field. You're a leading light in our field. And I can't think of a better person to be at program at the National Institute of Health, helping guide the future of vision science, cognitive science. You're a beacon to folks in the field.
That's sweet of you. I feel very privileged that I mean, it was sad for me to leave, but I feel privileged that I can actually have an impact now, maybe a little bit broader.
I do think that we started out with what you had to do to get to where you are and the trajectory in your life, and in the struggles and the trials and tribulations comes fortitude and the ability to stay focused and to stay at things, and that's one of the hallmarks of the way in which you've approached science over the years. And I know I speak for the field that we're thankful for that.